All right, example 4 from 13.6 on the trig ratios for right triangles, where we have a police helicopter is providing protection for an important person. That's interesting. Wonder who that is. The helicopter needs to be far away so that it can remain unnoticed. Got to be sneaky, yet close enough to respond if needed. Now, the helicopter is 1,500 feet above the ground and sights the person at an angle of depression of 24 degrees. That's what this picture is here. Angle of depression is from the helicopter. It's a plane in this picture, but just to illustrate what the angle of depression is. The angle of depression is right here. So straight horizontal from the ground, parallel to the ground. The sight, line of sight from the helicopter to the person, that forms the angle of depression. So this angle is going to be 24. We'll have a picture in just a second here. We want to know how far is the person from the point on the ground directly below the helicopter. What this is asking here is how far is the person from the point on the ground directly below the helicopter. Directly below the helicopter, in this place the plane, is right here. We want to know how far is this person from this point. So what's this length is what we're looking for here. So a picture looks like this. Here's a helicopter. Angle of depression is 24 degrees as indicated. We know that the helicopter is 1,500 feet above the ground, and we're looking for this length right here, or if we apply it to this triangle up here, it's going to be this length here, from the helicopter straight here to above the person. So we're looking for this length. We know this is 24 degrees, and then we also know that from this point directly above the person to straight down is 1,500 feet because that's what we're told here. This picture is not drawn to scale. As you can see, this person is probably about 500 feet tall, maybe if we estimate there, and a lot bigger than the helicopter. So this is not drawn to scale. Please just play along. So what we're doing here is we're looking for this length. We know this length. This is 1,500, and we're looking for this length here. We have this angle of 24. So with respect to the angle that we know, we're looking for the adjacent side of this angle, or the adjacent side of the triangle to this angle. And we have the opposite side. So we're looking for the adjacent. We have the opposite. Opposite and adjacent pertain to the tangent function. So what we're going to do is use the tangent function. Oh my goodness, it's Byron Buxton. That's the important person. Now this all makes sense. Now it makes sense. Okay. Anyway, since Byron Buxton needs this protection here, we're going to use the tangent function because we're looking for the adjacent side and we have the opposite side. We're going to take the tangent of angle 24. The tangent of 24 is equal to 1,500, the opposite side, divided by the adjacent side, because the tangent of any angle is equal to the opposite side divided by the adjacent side. So we have to find out that we know that the tangent of 24 is equal to 1,500 over x, and we have to solve for x. So what we're going to do here is multiply both sides by x to get x out of the denominator. We're dividing 1,500 by x, so let's multiply x on both sides. So therefore, x times the tangent of 24 is equal to 1,500. And now we're doing x times the tangent of 24, whatever this number is. We'll type that into a calculator eventually and find out what that is. But if we want to isolate x, solve for x, we're going to divide both sides by the tangent of 24. So dividing both sides by the tangent of 24 will give us x by itself. So 1,500 divided by the tangent of 24, type in tangent of 24 in the calculator, and you will get approximately 3,369 feet. So therefore, this helicopter straight over here, so right above the person, is about 3,369 feet.